Hi, we are students of second of Ari, and our group is formed by Gabriel, Román, Luken, Jodar, Anaitz, Zabala, and Adur, Insausti. We have carried out the third challenge of the course, which consists of creating an automated stock where a robot will move 5 pieces from one platform to another. For this, we will program the robot to make pick and place movements.
In this challenge, we have used the Robot Studio program, which is the program used with the ABB robots. This program allows us to program the robot and simulate the movements on the screen. Once it works in the program, we will be able to transfer the program via pendrive to the controller of the robot. We can adjust settings in the Rapid program, for example, offset point position that we have done with zooms. Through the variables px, py, and pz, we can make zooms of the discharge point offset. As for the tool, we have a pneumatic gripper that works by opening and closing. The pneumatic gripper will go into the workpiece in the closed position and will open once it is inside and grip the workpiece. The design of the tool has been a very important part of this challenge because without the correct functioning of the tool, it wouldn't be able to pick up and drop the boxes. As you can see, inside the smart component, we have applied a logic to be able to assign each operation, picking up the pieces with an attach action and to release the piece with a detach. Also, for all this to work, we can also edit these actions to open and close the gripper. It's very important that we configure the station logic.
In the specifications section, we will tell you everything we had to use to make the process work correctly. First of all, we had to use a solenoid valve to make the pneumatic gripper work with air. To do this, we had to connect pneumatic air tubes to the pneumatic gripper. In addition, on the input-output panel, we had to connect the ground of the solenoid valve to the ground of the input-output panel. Then, we had to transfer 24 volts from one of the inputs of the panel to an output that will be associated with the pneumatic gripper. Finally, to finish with the control of the pneumatic gripper, we have associated a button of our command, with which we will be able to control the pneumatic gripper, that is to say, it opens and that it closes at any moment. On the other hand, we have created an output of process finished, which will be in charge that at the moment in which the operation finishes, it transfers a warning to the other robot to know that they can already begin with the rest of the process. As you can see, the process of our robot will be shown here and you will be able to see the goal of the challenge. To begin, pressing the start button will start the sequence. The robot will go down to the position where the boxes are placed, and using the pneumatic gripper, it will pick up the box and move it to the base where they are stored. Afterwards, the robot will repeat this process. On the other hand, every time the robot opens the pneumatic gripper, the output will be activated to show that it's working.
Now, let's go with the simulation on an ERB 120 robot. In this plane, you can see the robot, the two platforms, loading and unloading, the pieces that we will move, and the tool that is fixed on the robot. This sequence will be initiated from a controller. For this, the robot key must be in manual position. We must also hold down the dead man's button. Once you have done all the above, press the play button on the controller. In our particular case, we added another start button, which we have linked to the first button of the controller. The robot will start to move when we press that button. The sequence will start with the robot in the home position. Firstly, it will move to the vertical offset of the first point, where it will make a smooth descent to put the pneumatic gripper into the workpiece. Once it has reached the position inside the part, the grippers will open and grab the piece. Then, it will return to the offset, making a full vertical movement. When the loading sequence is finished, it will return to the home position, and then unloading sequence will begin. The robot will move to the vertical offset of the first unloading point. Once it has reached that position, it will slowly move down to the unloading point, where the gripper will close and leave the piece in that point. After that, the robot will return to the offset and end the sequence in home position. This cycle will be repeated 5 times, since we have to move 5 pieces. For this purpose, we have added a counter in the rapid code to count the sequence performed and to let the robot know in each cycle which position it has to reach to pick up the piece. When it has completed all 5 cycles, the robot will give an exit signal to let the other robot know that it can start moving its feet.
We had several problems during the challenge, which we had to read the program several times to solve. The first problem was the positioning of the boxes. We were unable to place the boxes in their positions because the offsets on one platform were not the same as on the other. To solve this, we changed the rapid code by adding a counter, so we could configure the position each time the counter counted. Once this was changed, the robot still stopped in the third cycle, warning us that it could not reach the next position.
This was quite strange for us, as we had previously found that the robot reached all positions correctly. However, we moved the unloading platform a little closer to the robot and solved the problem. Another problem we had in the end was that the robot didn't grip the part properly. For this reason, we have lowered the loading and unloading points so that the gripper can grip the piece better.
To conclude, we have learned new concepts about robotics and we have been able to overcome adversities. We hope you like it.